Hi, I'm Dr. Christopher Sutton. Welcome to my Introduction to GIS video series. In the previous videos, I covered major categories of map projections and their commonly adjusted properties. In this video, we will discuss choosing a map projection based on the area being mapped. Let's examine some mapping scenarios and the possible map projections that you would use. We'll begin with world maps. For general world maps and atlases, choose a projection that's based on aesthetic appeal without large size distortions. You want to avoid conformal map projections where size distortions are quite pronounced in the high latitudes. What projections are appropriate for general world maps? The mall-wide projection, which you will recall from an earlier video is a pseudo-cylindrical projection, is a good choice, as is the natural Earth projection and the Winkel-Tripel projection. If you are mapping data on a global scale, choose an equal area projection. These projections are best for such purposes because they keep size relationships intact. Examples of these projections include the Robinson projection and the Goods-Homolocene projection. Goods-Homolocene is particularly effective when the data being mapped is constrained to land areas of the planet. If you are mapping oceanic data, you might choose the Spillhouse projection. When you are mapping the equatorial regions, cylindrical and pseudo-cylindrical projections are good choices. Commonly used projections for equatorial mapping include the Mercator, the Plate Carré, and the mall-wide projections. If you are mapping the mid-latitudes, conic projections are effective, especially if the area being mapped has a greater east-west dimension than north-south dimension. We map large mid-latitude areas such as the contiguous United States, Europe, and China using conic projections. Commonly used projections include the Albers equal area conic projection and the Lambert conformal conic projection. If you are making a map of a hemisphere, planar and conic projections are effective. Planar projections like the orthographic projection are frequently used when making locator maps, as such projections display Earth as being viewed from space. Here we see an orthographic projection focused on the equator, and another focused on East Asia. In addition to planar projections, you might see the Lambert azimuthal equal area projection being used to portray a hemisphere. This projection is commonly used in maps of North America. What if the area you are mapping extends farther north-south than east-west? In such situations, we commonly use the transverse Mercator projection. If you are mapping the polar regions, we almost always see planar projections being used. Here we can see examples of the orthographic projection being used for the Arctic and Antarctic regions. With local mapping, you have the greatest number of options when it comes to selecting an appropriate projection. In the United States, the transverse Mercator and Lambert conformal conic projections are widely used for local mapping as they form the basis for UTM and the state plane coordinate systems. I will describe these two systems in later videos. We'll wrap up our overview of choosing a map projection with this graphic. It shows how you might go about choosing a map projection and what kinds of map projections are appropriate at various scales. Note that this graphic also includes web maps. Oftentimes, if you are using a web mapping application, you are stuck with the Web Mercator projection. This is not true for all apps, and in some cases, you can change the projection within the app. In ArcGIS Online, for example, if you upload a projected layer and then move that layer into the base map, the web map will use that projection. Generally, changing map projections in web maps is a bit more challenging than in desktop GIS applications. If you are producing web maps, check the application to determine if you can use a projection other than Web Mercator. Note that this graphic shows recommendations for projections at various scales. It is not a comprehensive list of all appropriate projections in all circumstances. You certainly may use other projections. Just make sure that whatever you use is appropriate for the area being mapped. As noted in the previous videos, you will often need to adjust the parameters of a projection available in the software to work best with the area being mapped. Refer to that video for the steps that you take to modify a projection. This wraps up our introduction to map projections. In the next set of videos, we will cover the various ways we determine coordinate positions of features.